welcome back to the channel, and today we're going to be making a video about stall detection and what it means in Ev3. Let's start off with today's lesson objectives and what we're going to learn in today's lesson. Today, we're going to learn what stall detection is and why it's useful. We're going to learn how stall detection can help your robot recover from failures. And finally, we're going to learn how to move on the next block when your robot is stalled. So, first off, what is stall detection and why you should use it? So, stall detection is a program that stops your motor when the motor gets stuck. And many FLL teams, including mine, have faced motors getting stuck in their programs. And this is a huge problem and it is not good because if you're an FLL team in a competition, you usually have to grab your robot when the motor is stalled and you'll get a touch penalty, which means that you'll lose points just because your motor stopped in the program. You cannot finish it and you have to grab a robot and bring it back to base or home. So this is a huge problem and today we're going to learn the program that you can use to fix this and the reasons behind it. And when you use stall detection techniques, your robot will move on to the next program block. And in this video, the robot needs to move the arm down before it says good job. However, if the motor stalls, it will never say good job. You can click on the video in the ev3lessons.com website to learn more about stall detection and to watch this very interesting video. So, move degrees versus move seconds. So, in our lesson on move blocks in the intermediate tab, we said that if you use move degrees, your motor may get stuck. And we told you that move seconds helps avoid stalls, but is not as accurate when you're going forward or when you're turning or any of the above. And that is true. But are these the only choices? How can you use move degrees and prevent stalls? Because move degrees is very accurate and reliable compared to move seconds. And I've made a video covering move degrees versus move seconds and finally versus move rotations. So be sure to watch that video because there are many pros and cons of all of these different move types. And we'll show you how in this lesson to use that. So the requirements in this lesson, you need an arm connected to a motor. We have set our code to use a medium motor connected to motor A, and this can be changed to suit your team's needs and whatever situation you guys have been provided. And you can follow along using the Ev3 code provided, and step 1 will begin first. So we have step 1, and I'll be explaining more as you guys can follow along in the LEGO Mindstorms programming app. So this code was originally made by Hooser Girls, and you can find more information about that right here. And the goal of step 1 is to stop the motor from moving when the arm hits an obstacle. For example, a wall, grounds, mission model. And the pseudocode is you have to turn the motor on and then continuously check if the motor has moved over 1/100th seconds. And if the motor has not made progress over 1/100th seconds, stop the motor. So right here, we got the code and I'll be explaining more about it. So we have the start block and we have turn the arm motor on, which kind of resembles your program, which will make your motor start moving, and this takes the place of it. And right here, we got the motor reset block, and we have a wait block to ensure that the arm starts moving. And now we have a loop block, and inside the loop block, we have two parts. So we have checks if the motor has moved in 1/100th seconds. So we have this block, this motor A input goes into this input, and then we have this motor A right here, and that goes into B. You subtract them. And we have a wait block right here for 1/100th seconds to simplify that. And then we have the output of here, and then we put that into A. So we make sure that A equals 0, because if the motor does not move, it exits the loop. So if A is 0, then you take the output and take it into that loop. And this is a true or false condition. So if it is true, then it'll exit the loop, and then we'll go to this block, which finally stops the motor from moving. So you can review this last clip if you're having any troubles, or just put your questions in the comment section down below, and feel free to do that because I'll be really happy to answer them. So we have step 2A right now. So step 2A is to add this part, so we have a little bit different right here. So we have everything the same, right? So, but we take this input instead of right here, and we will take this input and put it into A, and we'll also put it into this A right here. And instead of doing this, we will also take that and put it right here. So we have the A from output going to here, and the A from this output going into here. So this makes sure that A is greater than 90, and if it is, the output will go into this B, and this output will go into this A. So this is if the robot arms get stuck, or if the robot reaches 90 degrees, exit the loop. So finally, this will take here. So right here, we have this output, and we bring it over to B. We have this two outputs. We bring one to A and one down to this future A. And then we take this output, put it to A. We take this output, put it to this A. And we have this output and put it into this B. Take that output and put it into the loop. So this is really confusing, but over time you'll get the hang of it. And I guarantee you that you'll be much more comfortable with this information once you review a couple times. So now we have step B, and the goal of the step 2 program is to stop the motor from moving when the arm hits an obstacle or if it has moved in amount of degrees. And here's a pseudocode. Turn the motor on as always. Continuously check if the motor power is 0 or has reached the target degrees. And if the motor has not made progress, which is power equals 0, or reached the target degree, stop the motor. So right here, we have this program still, and we have the 0.1 as always, and we have these. So checks if the robot has reached 90 degrees. So we have that. Take this output and put it into this B. And this checks if the motor power is 0. Although it is called power, it actually means the current speed of the motor, which should be 0. And take this output and put it into this A. So this is if the robot's arm got stuck or if the robot has reached 90 degrees, exit the loop. So we'll take this output and put that into the loop exit condition. And this stops the motor from moving, and we just say good job. And these blocks are just for the video, so you can remove this if you want. You can remove these two blocks. And this should be the final block if you do not want the good job and the timer. So you can always find this on the Ev3lessons.com website. And it's been BuilderBro07. I hope you enjoyed today's video. Be sure to like and subscribe for more content like this, and sometimes also even more fun content. And be sure to have a great rest of your day. Build on, and I want to see you in the next video. Bye-bye, and peace.